Hello friends, in this video we will explore about HashSet and set interface. So a set is a collection of uniqueness over hashing. So uniqueness in the sense the elements are stored uniquely. That means duplicates are not allowed in case of a set. First, let us look at Java set interface. Before we study Java HashSet, let us look at the set interface which is implemented by this HashSet. The set interface represents a collection that does not allow duplicate elements. So previously we looked at array list and linked list. So these Java collections allow duplicates, but here the set interface and the implementation collection classes like HashSet and treeset, it will not allow duplicate because these collection implements set interface. So set means simply a collection that does not allow duplicate. Some of the implementation classes are the HashSet, enumset and treeset. So this Java's collection implements the set interface. That means elements stored in HashSet, enumset and treeset does not allow duplicate entries. In this video series, we will look at HashSet and treeset. And in this present video we are going to look at HashSet. Let's see a quick overview of the methods exposed by the set interface. The below table lists frequently used methods, and if you look at the methods are pretty same with what we saw previously. So the method add adds an element and removes an element. Clear, that will clear all the element. Is empty, checks whether set is empty or not, and the size returns the number of elements presently available in the set. And the contains method tells whether the supplied object O is part of the set, the part of the collection. And then you can retrieve the iterator and iterate over the element. So in the last two videos we talked about iterator and list iterator, right? Here you can take iterator by calling the iterator method and you can iterate over the hash map. So the implementation methods are same, but if you see, since the set interface states that it doesn't allow duplicate, there is a difference how the add method is implemented in array list, linked list and the set interface implementing classes. Say for example here, since we are talking about HashSet, we will take a HashSet. So when we add an element through linked list and allow array list, they allow duplicate element. But here if you make a call to add with a duplicate element, the element will not get added. So this is how it differs. Alright, so this is the methods, these are all the methods exposed by the set interface. Now let us look at the HashSet implementation class. So this is the set is the interface and HashSet is the implementation class of that implementation class of the set interface. The HashSet class implements set interface. So HashSet is a Java collection class which implements set interface. So it also implements a collection interface. In this video we are going to concentrate on the set interface. The HashSet acts an hash table. Hash table can be seen as buckets. So we will dig deep into the buckets in the next video. But here in this video, we will concentrate about the hash set and its functionality. In hash set, insertion order is not preserved. So in array list as well as in a linked list, the elements are inserted in the same order we make a call to the add method. So if we make a call to add method to add 5 integers, say 1, 2, 3, 4, 5, it will be added in the same order 1, 2, 3, 4, 5. But in hash set, we cannot guarantee the insertion order. Sometimes the insertion orders are shuffled. The hash set distributes the elements evenly across the buckets. So it uses the hashCode function because it returns integer, and it uses that integer value while it is distributing the elements across the bucket. So this dispersing is useful later when we want to pick an element. So when we want to pick an element, we will go to a specific bucket and we will search only inside that bucket to pick an element. This way we can improve the performance of hash set when we are taking an element or when we are making call to the contains method. The element stored in the hash set must override equals and hashCode methods. So we already talked about this in the video series. We doesn't talk about the collection, but we talked about how to override equals and hashCode method. So you can refer the video here in the playlist. In comparing two objects, we overridden the equals method, and we introduced how to override hashCode method. But in that video we told that we will see its real usage when we make use of the collection. So it's time to see why hashCode is required, and in this video you are going to see that. But if you want to know how to override equal and hashCode method, you can watch these two videos in this playlist. Alright, now let us go ahead to Eclipse and explore the HashSet functionality. So here is our HashSet demo project. So in this we have two classes. One is placed in the product.java and another one is HashSet test. So this has our program main entry. So inside the product class, we already saw this many times. I will run it quickly. So it has two members. One is a product ID and another one is a product name. Then the constructor will take two parameters, ID and name, and initializes the internal members. Then we have a override for a toString just to represent our product object in terms of a string. So it will show product ID and product name, and in between there is a separator column. Alright, next we have a getter and setter method to get the product ID, set the product ID, and to get and set the product name. So simply the getter and setter for these two members. Alright, now if we go to HashSet, it's an empty class. We are going to implement this HashSet. So here we divided this into 5 test runs. So in the first test run, we are going to create a HashSet, then print the product. That means our HashSet is going to store the product, then we will print the product. Here insertion order is not guaranteed. So sometime it will print in the same insertion order, sometime it won't. Alright, Now we will go ahead and implement. First we will import the required classes. So the HashSet class is the implementing class and set is the interface. So the set interface is implemented by the HashSet class. So we imported both the classes from java.util.package. First we will place that in our example. So now the warning states that I imported some package and doesn't use any class from those packages. That means it states we are not using HashSet and set. Anyhow, we are going to use it soon. Now, if you see, this is how we create the HashSet. In the right hand side, we place the HashSet, and within angle bracket we specify product. That means this is a strongly typed collection, so the HashSet can store only the product. So on the right hand side we are using the set interface because HashSet is implementing the set interface. That's why we placed the set. Within angle product we placed the product. That means we can read this as set of product and the reference name is products. Alright, so create HashSet and hold it in the set interface. So that's what we are doing. Alright, now we created the collection. Next we will create some sample product because we are going to store the product in our set interface. So after creating these 6 product, we need a method to print the elements. So far we haven't added this product to the HashSet. Okay, we will do it as part of step 5. In step 4 what we are doing, we are creating a method called print product that receives set interface as a parameter. So here if you see, there is one system.out.println statement. After that we are using a for each loop. So we are iterating over these products, whatever is coming as a parameter. So this is actually the HashSet object, but we are taking it with the set interface. Then we are iterating the HashSet collection through this set interface products. So in each iteration we will get a product and the reference is prod. Then we are printing that using the system.out.println statement. Now we will place this code. Since it's a method, it should go outside of the system.out.println. Sorry, the public static void main. Alright, our method is ready now. Finally, we add our product to HashSet. Then we are making call to this print products. So this product is the collection which we created, and this P1, P2, P3, P4, P6 are the product instances. And so here we are adding the product instances to the collection. That means to HashSet, products is HashSet, and P1, P2, P3 are the instance of product, and we are adding 6 product to the products HashSet. Next we are calling print product and we are passing our HashSet. Here we are taking that as a set interface. You can also use a HashSet and you can iterate it, but for simplicity purpose here I used a interface because we are dealing with the set interface function. So here we are iterating over that set interface. Alright, now we add this. So this will go inside our main function. So now all warnings are gone. Alright, now let us put a breakpoint here and we will examine it. So that's the end of our first test run. So our first set of code is completed. Now we will go for a test run, and so here first we are creating the HashSet. Let us put a watch on this product. So this is our HashSet and the HashSet is at present empty. Then we are making call to our right, first we are creating the products. We'll create one by one. There are 6 products which get created: pen, pencil, rubber, writing pad and sharpener. Next what we are doing, we are adding the product to our products collection. So each one is product here. We are going to add all these product to our product collection. So the very first product is added, and you can see that the HashSet will grow when we add the product. First 101 pen is inserted. Next we are inserting the product P2, so it's pencil. And if you see, rubber is in the third position. I mean the rubber is inserted first now. Next we are inserting pencil. Then fifth one is actually Eclipse, and Eclipse is inserted here, and P6 is a sharpener, and the sharpener also inserted into our product. If you see here, the insertion order is P1 to P6. That means we inserted it in pen, pencil, rubber, writing pad, Eclipse, sharpener. But if you see, the order is different: Eclipse, then rubber, then pen, then writing pad, pencil. So the order is not reserved inside the HashSet. Of course it has all the product, but it is not in the order in which we inserted them. Now if we print the product, it will print the product, but the order is not preserved. Here it is not printing it as a pen, then pencil, then rubber. So that's all here in this first part of the demo. Now we will go back to our example. Before that I will clear this. So in this test run we are going to add some more element, and we are going to observe that the set is allowing the duplicates. So in the PowerPoint slide we talked about the set. We told that set is an interface which does not allow duplicate, right? But here if you see, it will allow duplicates, and you will also learn why we need to implement a hashCode and equals. So at present, if you remember, in our product class we doesn't override equals and a hashCode. Alright, now first we will, for this test run, what we are going to do, we are going to add 2 more product. So one is product 104 and another one is also product 104. We are having a 2 reference, P7 and P8. So this is writing pad and this is a name not applicable. So if you see here, this is a exact duplicate of element P4, and element P4 is 104 writing pad. Here once again we are creating the same product. The reference is a different P7. So we are creating two products here, P7 and P8. Then what we are doing here, we are adding the product P7. Then it returns success or failure. Based on that success or failure, we are stating. So if it is returning false, then not of false is true. We say that product P7 already exists. Why? Because the insertion here failed, so it returns false when insertion is not possible. So here we expect that the HashSet should return false because it's a duplicate. The set interface will not allow the duplicate, so the HashSet will not allow duplicate. So we expect that this add will fail. Similarly, we are adding the P8 and the string here is name not applicable. So this is not exact duplicate. However, let us see what happens. So code snippet 5 is already added. Now we will add the code snippet 6 here. Alright, now we will move our breakpoint to this location. So now we will test our P6 code. If you see here, 104 writing pad is already there, and now we are creating P7. Then we are creating a product P8. The IDs are same for both, but the name differs. Now we are trying to add P7, and if you see the return is true, that means it added the product. And if we look at here, there is 104 writing pad, and there is one more 104 writing pad. That means our HashSet is allowing duplicate here. So it's not doing the right job, right? Now, if we add P8, that will also get added. And if you see, there are 3 products with the same product ID, 104 name not applicable, 104 writing pad, and one more 104 writing pad. Alright. Now, to avoid this, that's why we should implement the hashCode and equals method. So the HashSet is a set interface based collection implementation over a hash table. Since it's over a hash table, we are forced to implement hashCode as well as equals method. So here is our theory test run. Here we will override the equals as well as the hashCode. So when we override hashCode, as per the Java documentation and suggestion, we should override the equals method also. So after implementing this equals and hashCode, we will check this same piece of code and see how it works. Alright, so that's the purpose of this test run. First we will override equal and hashCode, then we will check for the duplicates. First let us look at the hashCode implementation. Here if you see we want to say that a product is duplicate when the product ID already exists. That means here we are not considering the product name, we are going to consider only the product ID. So if you want to consider product name also, then you should generate hash code by placing product ID comma product name. So the objects.hashCode method will receive n number of parameter. You can separate it by comma. So here we are implementing our hash code only based on the product ID. The hash code is implemented. We are going to implement this hash code inside our product class. So our product class has two members. One is product ID and another one is product name. Since we are going to skip product name and we want to maintain our hash set based on product ID, the uniqueness will be maintained based on a product ID. We are generating the hash code only for the product ID. But if you want to maintain the uniqueness based on multiple field in a class, then you can separate that by comma here in this hash code method. So this object.hashCode method will return an integer value and we are storing that inside X. Next we have four system.out.println statement. So here we are just saying that our collection called our hashCode method. So this is the hashCode method. So we can store this product class in any hashCode implementation. That means you can use this product class in HashSet as well as hash map. So here we are going to see HashSet. So the HashSet will make a call to this hashCode method. Alright. So next we are stating that a hash code for this product name is X. So here we are generating the hash code, right? We are printing that hash code also. That's all. So just some system.out.println statement. Here the key statements are generating the hash code and returning it. So that's all. So these are all just for checking purposes so that we can understand better when we are making this a test run 3. So you will understand when it will make a call to hash code or those stuff. Alright, now we will implement the equals method also. So as per the standard, since our hash code involves only one field, product ID, the equals method should also involve only that product ID. So these are all some standard statement. Here we have, the console output statement. Here we are stating that collection called our equals method. Just to check when it is calling our equals method. Then the incoming object obj, we are converting that as a product class. Then we are checking this .product ID equal to incoming object which is casted as product prod.getProduct ID. So if you see here, we are referring in both hash code and equals, we are referring this, right? This means the calling instance and whatever is incoming, that is so there are two objects involved, right? One is the object and another one is the object inside the collection. So when we do our test run, you will get more picture into this. Alright, now let us copy this. So this should go inside. So this is code snippet 6, right? So we will add code snippet 7 inside our product class. So it's the product ID and product name. So the hash code doesn't take any parameter, so we use this reference and we generate a hash code. But if you see the equals method, so equals is just for comparing two objects, right? So one is the calling object that we use with this reference, and another one is the incoming parameter. So we are comparing both the incoming parameter and this reference. Based on that, we are returning true or false. Alright, now we will experiment our same method. So we just modified our product class, that's all. So previously this method failed, right? It allowed duplicate. Now we will test. So we will clear the output. So this is our product class. I mean, this is our HashSet collection. So as usual, we created two products. Now I am going to add P7. Remember, we implemented the equals and the hash code based on product ID only. We are not bothered about the product name. So ultimately, these two are considered as duplicate. Alright, now I am trying to add the product. Look at here, since we have some console output statement in the hash code as well as here collection called our hash code and a collection called our equals method. So now I'm going to add a product, and you can see first, if you see, collection called our hash code. So the hash code for writing pad, because that is what we are trying to add here, P7. So the hash code for writing pad is 104. So since the hash code is equal, then it makes a call to our equals method also to double confirm that the product already exists in the collection. So 104 writing pad is already in the collection. So when it compares the hash code for the incoming writing pad through P7, it takes this hash code 104. But the collection already has 104. It may be in some bucket. So this 104 from P7, it is searched along the bucket. So here first what happens when we are trying to add P7, the hash code for this P7 is calculated. That's why it called our hash code method. So the outcome is 104. Now based on this hash code, it will go and search inside the specific bucket. So we don't know in which bucket the 104 writing pad is. So for example, let us say that 104 writing pad is in bucket 2. So it will go and search only the bucket 2. Since here our collection is so small, you may not be seeing any bucket here. Alright. So once it finds the element, that means here also it will just check that hash code entry only. Once it finds a 104 matching 104 hash code, and here is also 104 and here is also matching 104 hash code, then it knows that this object has the possibility of matching. So for double conformance, then it will make a call to the equals method. Now equals method will 100% guarantee that the object in the collection equals to the new incoming object P7. So that's why it called our equals method also. So if we add a new element which is not matching here, then it will not call the equals method. Alright. Next. So it states that product 104 writing pad already exists. That means it is not adding that. Previously it added, right? Now we rectified that error. Now we are adding P4. even though the name is different, since our comparison is based on the product ID only. Let me clear this output. It will make a call to the hash code, then it will once again compares the equals method. Since equal methods compares only the product ID, this will also skipped, so it will not get added. And if you see, it called our hash code and it called our equals method also, and the return get failed. I mean the addition get failed. So both products are not added. So if you see, we added the collection with our product, and the collection is a HashSet, and HashSet called the method return inside the product class. So when we are adding the element, it makes use of the hash code and equals method. So when it started using the hash code and equals method, the duplicates are not allowed. So the contract of set also maintained. Set means a collection of unique entries. Now we are abiding to that rule. Now let us remove product from HashSet. So in this test run, we are going to remove product from a HashSet. The method is remove. So first we are removing product P3. We are checking the return value. Then if return fails, then we are saying that product P3 is not there. If you see, first time we are removing P3 and P5. Since these two are available in the collection, it will get removed. Next we are once again trying to remove P5. Since P5 is already removed, it will not be there in the collection. So if you once again remove P5, it will fail. If you see, since the products are unique inside the hash set, once you remove P5, then definitely that element will not be there. Since it doesn't allow duplicate, we can 100% say that the element will not be there in the hash set. So when we call the remove once again with this P5, the remove will fail, and we will say that product P5 is not there in the collection. After that, we are printing the product to see the removed product. That means the P3 and P5s are removed, and we will see the rest of the product stays within the hash set. Now we will place this code. So this is our code snippet 8. Code snippet 7 is there in the product class. So we kept our code snippet 8. Now we will remove this breakpoint and place the one here. Once again, we will start debugging it. So here is our hash set, and if you see, we are going to remove rubber, then Eclipse. We want to remove rubber and Eclipse. These two will get removed. So first, if you see, we are making call to remove method. The P3 rubber will get removed. At present we are in remove method, so once I execute that line, the rubber is removed. And if you see, it called our hash code. Now you may wonder that when we are adding an element, it compared based on the hash code. After that, it called the equals method also. But here equals method is not called. Why? Because the set is unique entries. When we are adding the product, that time itself, since we compared the equals method, once the products are added, it is 100% guaranteed that the objects are equal. So now when we pass P3 here, it doesn't call our equals method. That's one point. There is one more analogy. Since P3 is the same reference which was added through the collection, it doesn't check the equals method. So I think the second analogy is the correct one. Yes, the second analogy is the correct one. Since the P3 is added and the same P3 we are giving here to remove, so both references are same. That's why it doesn't make a call to the equals method. But if you create a new product like this, new product with a matching criteria, say for example, if you create a new product P9, new product of 105 clips, and then if we pass that, then it will make a call to hashCode as well as equals method. Alright, so the remove method will remove the element. We already saw that the product P3, which is 103 rubber, that is removed from this collection, and if you see 103 is not here. Since it is removed, we get return value as true, so we will not print that the product not there because the product is actually removed. Then now we are passing P5. P5 is 105 clip, that is also there here. Now when we make a call to P5, it will remove this element 105 clips. So it returns true, so we will not print this message P5 not there, that will not get printed. Now if you see, once again we want to remove 105 clips, so we are passing this reference 105 clips and we want to remove that from the collection. Since 105 clips is not there in this collection, this removal attempt will fail, so return will be false. You can see here also it is highlighted. So this time we will print product P5 not there. So here we say that the product 105 clips not there. So during the removal, if you see it still uses our hashCode override. Alright, now we are printing the product. It will print all the remaining product. Since we removed P3 rubber, that is not here, and P5, which is clips, that's also not here. That's all in this test run. Now we will go back to our last test run. So here what we are doing, we are making call to the contains method. We know that P2 is there in the P2 is pencil is there in the collection. Pencil is there in the collection P2, and P5 is clips is not there in the collection, so this will return true, and this contains this P5, this one will return false and this one will return true. So this is our last test run. Let us examine how the contains method works. Okay, P2 is 102 pencil. Since 102 pencil is there in the collection, it will return true, and you can see that here in the output. Similarly, when we test for P5, since 105 clips is not there, it will return false. If you see here, for the contains method also, we are making use of our hashCode. So it doesn't call equals method, right? Now let us see. P2 and P5, right? We will create a P2. There is P2. We will give it as a P10, then we will pass P10. This time it will call the contains method. Then we will create one more product. P11. Marker pen. And the ID is important here. 100 okay, we will make it as 102 pencil. So it's existing product, so it will return true. Then we know that 105 is already deleted. We can make use of that itself here. 105, and instead of marker pen I can say Eclipse. This time if you see, since the references are not same, or because we created a new heap location, but the content is same here. If you see 102 pencil which is already there in the collection, 104 clips was there in the collection, but we removed it as part of our remove test. Alright, now we will execute this and see. Now this time it will make a call to both hashCode as well as a equals method. If you see, this time it called our equals method, but because the reference is different this time. Previously, since the reference is same, it just generated the hash code and it doesn't call our equals method. Since here, if you see, once the hash code matches, before committing both objects are equal, it actually makes a call to equals method to double check that the products are already there in the collection. So if you see 102 pencil, it generates hash code for P10. The hash code is 102. Then it makes use of this hash code to search inside the bucket, and once it picks 102 pencil, then it compares these two using the equals method to double check that the objects are actually equal. So once they are equal, it says that the collection contains 102 pencil. So if you look at the Java documentation, they state that the hash code, there is a error tolerance. So when two hash code are matching, definitely the object will be equal, but with a little error tolerance. It may be 0.0001%. That's why it makes use of the equals method before committing two objects are equal. Alright, now when two hash code are not matching, then 100% the two objects are not equal. So when it is not matching, we no need to compare equals method. So Java won't compare the equals override. So here in this case, we are making call to 105 Eclipse, and we are saying we are making call to contains method. And if you see, the 105 hash code is called. Since 105 hash code is not here, so it doesn't compare equals method after that. So if there is no matching hash code here, then definitely the object is not here in the collection. Alright, I'm not sure whether I made you understand or confused. Alright, you just try writing this code in your Eclipse environment and test it so that you get more clarity over here. So that's all in this video. A quick summary is here. If you see, the set interface is for creating a collection with uniqueness. So there are multiple classes which implements this set interface. For example, hashSet, enumSet, and hashSet and enumSet implements the set interface. Even the hashSet, enumSet, and treeSet also we can include. So all these implements this set interface, which means this set maintains uniqueness of the elements stored inside the collection. So first we looked at some of the set interfaces function, then we looked at the hash table. Then in the demo we saw how to add element to the hash table. Then we looked into the need for the hashCode and equals override. What happens if you want to override that? And we saw that our hashSet allowed duplicates. Then we looked at how our hashSet calls hashCode and equals method. We saw sometimes the equals method is called and sometimes the equals method is ignored. And we also explored under what situation it calls the equals method and under what situation it ignores the equals method. Alright. Thank you for watching this video. If you want to get more updates, subscribe this channel so that you will get notified. Thanks for watching. Bye.